We're going to be finding one-sided limits of a function. Collectively, the left and right limits of a function are called one-sided limits of the function. So basically, when you see something like this, you're saying limit as x approaches c from the left. So this is where the left comes from, and it's technically referred to as the left limit, or commonly referred to the left limit, and it's where x is less than c. So it's coming from the left, approaching the constant. And similarly, we have the limit as x approaches c from the right side. It's called the right side limit, and it's where x is bigger than the constant. So you're coming from the right to the left. Sometimes the teachers will say above, but sometimes it's actually below, and it gets closer and closer to c. And we have one with the next one that's a piecewise function. Then the rest of the problems that we're going to be doing are basically very simple, and I'm going to go fast through those. We really want to get to the next video and talk about continuous functions. So let's look at this. We have a piecewise function, already graphed it, and we want to find the limit as x approaches 2 from the negative side. The limit, well, from the left side, so this is from the left. The limit as x approaches 2 from the right. And then to have the limit of just 2, these two have to match. And that's where we're going to go into continuous functions. Well, if we look at this from the left, as we're looking at this part, this is from the left. This is our 2. We're approaching x. X is approaching from the left. As it approaches to x, we get closer and closer to 3. So the limit as x approaches 2 from the left of 2x minus 1 is going to equal to 3. So let's go back. We're looking at this. So this means that x is less than my c. My c is here. This should be a 2. Glad I looked at that. So my c here is 2. Now, for this one, we're going to see what happens as x approaches from the right. So we're looking at this one right here, this equation here, which is here. And we're going to draw, and it gets closer and closer to 0. So the limit as x approaches 2 from the right of 2x minus 1 equals 0. Okay? Now, because these two limits aren't the same, the limit from the left side does not equal the limit from the right side. The limit, let me do this in red, the limit as x approaches 2 does of 2x minus 1 does not exist. And that's where we're going to talk about continuous. This is not a continuous function. As you go up, it jumps. All right? So it does not, it's not continuous. Now the rest of these are basically simple problems that we did in a previous video. Basically, we're just going to plug in the 1, since these are all continuous functions. And it's going to be pretty basic math here. So the first one we're going to do is the limit as x approaches from the right side with 1. And all we're doing is plugging in 1. So we do 2 times 1 plus 3. And that's going to equal 5. This one's going to be 4 minus 2 times 2. And that's going to equal 0. So you're just plugging in, because these are linear functions and they're very continuous. We're not dealing with piecewise functions. Same with these. These are cubic functions and square root functions, and they're continuous. So we're just going to plug in the 1. That equals 2 plus 5, which equals 7. And this one is going to be 3 times 2 squared minus 8. And that's going to equal 12 minus 8, which equals 4. All right, then we have sine. This equals the sine of pi over 2, which equals 1. 3 cosine of pi equals 3 times negative 1, which equals negative 3. Okay, and then this one, we're going to have to factor, which we did in a previous video. And we're going to get x minus 2 times x plus 2 all over x minus 2. These cancel, and you plug in 2, so the limit x approaches 2 from the right, and we're just going to put the x plus 2 equals 2 plus 2, which equals 4. The next one, again, we're going to just factor a little bit. And I'm going to factor out x, and I get x squared minus 1 over x minus 1. I'm going to factor it further. So we're approaching from the left side. I'm using the difference of the squares here, formula for the factoring. This cancels, and I plug in 1. I get 1 times 1 plus 1, and that's going to equal 2. Okay, we're going to factor this one. Don't forget, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. You'll be doing this a lot in calculus. Make sure you know your sum and difference of cubes. So we're going to approach negative 1 from the left side, and I'm just going to factor. So that's going to be x minus 1 times x plus 1 over x plus 1 times x squared minus x plus 1. These cancel. I plug in negative 1. I'm going to get negative 1 minus 1 over negative 1 squared minus a negative 1 plus 1. And that all equals negative 2/3. Okay, I have 2 more. We're just going to factor again. And we're going to get the limit as x approaches 0 from the right side. And it's going to be x squared over x minus 1 over x squared times x squared plus 1. The x squares cancel, so we get the limit as x approaches 0 from the right side of x minus 1 over x squared plus 1. Plug in the 0, and you get negative 1 over 1, which equals negative 1. Have 2 more here, where x is approaching negative 2 from the right side. I'm going to factor, so I'm going to get x plus 2 times x minus 1. In fact, do the highest common factor, x times x plus 2. These cancel. Plug in the negative 2. You're going to get negative 2 minus 1 for negative 2, which equals negative 3 over 2, which equals 3. This is negative 2 over 3/2. And the last one, we're going to factor again. This is going to equal the limit as x approaches negative 4 from the left. And this is going to be x plus 4 times x minus 3 over x times x plus 4. This cancels. And we're left with the limit as x approaches negative 4 from the left of x minus 3 over x, which gives you negative 4 minus 3 over negative 4, which equals negative 7 over negative 4, which equals 7 over 4. And that's all. Please see my next video on continuous functions, and I will have more graphs on that video so you can see better what's going on.